Hello everyone. So welcome back to another episode in my Unreal Engine 4-legged character tutorial series. So here I'm going to do this. So when this character walk on angled surface, I'm going to rotate the character to align with the surface like this. Actually this is the first step of making this character procedurally adapt to the terrain he's walking on. So it doesn't look very realistic still, but this is the first step. So yeah, let's see how to do this today. And this episode is sponsored by this generous patron. Thank you very much for your support. Right, so I have updated the project to Unity 2021.1 version, and this is what we have at the moment. We have the 4-legged character. It can walk. So right, the next step I want to do is implementing eye case for the character. But to test eye case, we need some uneven terrain. So let's duplicate this one. And create some, oh, this is a floor, that's also a cube. So we could add a terrain and make some mountains, not really mountains, some uneven shapes. But when there is a terrain in the project kind of lags, so therefore I'll just add some cubes and test. Okay, this would be enough. So at the moment, if I walk on these cubes, you can see the character doesn't really match with the landscape. So let's see what we can do to fix that problem. So first let's see how to align in the forward direction. Right, so first let's see if we can modify the character to match with the terrain using the bones that this character has. So it has a root and pelvis. Okay, so I think if we rotate this, this is my plan to match them in the forward direction. That means this way I'm going to from the spine keep the left leg without any change and move it to touch the ground like this. And what if we rotate it from the spine? Oh, that doesn't look good. Right, then the next thing that we can try is we can rotate the complete character to match like this, but this is not correct because the legs should be straight, legs should be vertical. Then we can rotate these thighs to make the character vertical. Back legs like this, and front legs let's see, Yeah, like this. So that's basically what I want to do. uh, Wait, let's see what happens if I keep these changes like this and play. Ah, they are reverted. Okay, I'm just testing. Because I haven't attempted something like this before in Unity. So, right. Alright, so how do we do this? So first, let's see how to rotate the root. So I guess we will have to add some local rotation to the root bone to achieve this. So let's open the animation script, and here let's define another function, void update. Okay, no, actually update character bonds. That seems good enough. And here let's call that function update character bonds. So now we have a reference to animate, so we can get here any set. Oh, why am I not getting any suggestions? We have some error here. Yeah, actually that's I need suggestions, otherwise it's hard to do. Right, it is fixed. Now here let's try this. Dear Annie, set bone. First let's try to get bone transform. Which bone we need? Is there a way to get a set of bones? Well, this is not a humanoid, so we can't use the human body bones. Yeah, well, actually using the get bone transform, we can only get the bone transform for humanoids, but this dear character we have here is not a humanoid, it's a generic version. So what can we do about this? So can we turn this into a humanoid? Well, I don't know, let's try that. Okay. Oh, it's look like her. Right. Upper leg, or thigh, or calf, foot. Okay, I think, yeah, that looks good enough. Okay, let's see. We still. Oh, what happened there? Right, now let's see what happened to other animations. We have to use this avatar, right? Oh, this doesn't have animations. Oh well. But if I set to humanoid in these individual animations, it works like this. Okay, so for the running also, let's set it to humanoid. Can we just use this? When I give create from this model, it looks alright, but let's see how it looks with the deer model. Legs are wrong. Okay, looks like we will have to revert it. That's not it's a failed attempt. I'll change it back to generic. Right, it is working again. Okay, so now how do we get the... Okay, let's create a reference here and see if we can update it in the runtime. So transform root. I don't know what would happen. Let's see. Oh, we have an error. Let's use this hashtag, not the root. Okay, and yeah, its rotation is minus 90 always. No, 92. What about the root? It is always 0. Alright, then let's use the root here and let's see if we can update it. Root set local rotation. Let's try something like this. I just want to see if we can modify it this way. Right, but there is something called late update in Unity. So I think if I call this update character bones in the late update, those changes will be applied, because in the update loop, I think the character rotation and everything is applied from the animation. So therefore whatever I do here is overridden by that. So let's cut this and implement void let update, and let's call this function. Right, let's see. Yeah, so okay, so this is, oh, I can't move, but yeah, that's, we have something now. Okay, right. Alright, so yeah, we can do something with this. Right now, here, instead of just setting a random value, I need a way to determine the exact angle of the ground in the forward direction of the character. So to do that, let's try something like this. We need to do 2 raycasts. Right, so for that, well, let's create 2 more references. TFL stands for front leg, RL stands for rear leg. No, let's change the name. F stands for front. Instead of T, we have left leg and right leg also, because this has 4 legs. So we will call this, let's call hands. Instead of front and back, let's call hands and leg. So TLL stands for left leg, TRL stands for right leg. So yeah, let's call this left H, left hand. Okay, so we can have just like this. We can have RL and RH, right leg and right hand. So whatever the front, we call the front legs of the deer as hands. So that's, I guess that's less confusing. So how do we define them? Okay, here now LL, let's use clavicle. Actually, why shouldn't we use the same names as here? That would be better. Left thigh and right thigh. Yeah, let's call them like that. L, thigh, clavicle. R, thigh, clavicle. Okay, now R clavicle should go here, L clavicle should go here, and L thigh is here. Oh, L clavicle is here. R thigh is here. Okay. Oh, okay. Now let's define a raycast hit. Then let's do a raycast downwards from the right clavicle and the right leg, so that using those hit points we can determine the rotation of the land. P6 raycast T, yeah, let's use left clavicle position, that's the starting position, and the end position is left clavicle position plus vector 3 up down, let's use down, into how much? Let's see the difference if I make it 2. Okay, I guess then like 10 would be enough. Actually we only need to give the origin and direction and distance, so yeah, 10, and then how to get the results, out hit, it's not correct. We need to give hit in 4 before max distance. Okay, so this should be hit in 4. Hit 10. Alright, okay, now let's have 2 hit objects, F hit, which stands for front hit, and R hit, which stands for rear hit. Oh no, yeah, let's call this C hit, or clavicle hit, and thigh hit. Okay, similarly we have to do another recast hit. This time T, instead of clavicle position we need to use thigh position. here thigh hit. Okay, now let's draw. I'll comment this part, debug, draw line, start end. Okay, clavicle hit dot impact point. Okay, this point, let's use it as the end, and as the start let's use T L O L clavicle dot position. Oh, here we have a typo. It should be clavicle, not V. Similarly, debug dot draw line T. This is just to demonstrate, just to see if the lines are going, raycast are going in the way I intended. Let's see if the lines are going in the way intended. Well, honestly, I don't see any line at all. Oh, wait. Here we have lines, but they are over here. Why is that? Oh, wait. Unassigned reference issue. Left clavicle, I haven't assigned it. Is that the problem? Okay, now you can see the lines. So I guess it is right. Yeah, right. Now, using those 2 points, well, first we need to make sure both of this raycast to have an actual hit, otherwise we would have a problem. So clavicle hit dot oh, we can't check it here, but we get a boolean value here. So let's change this a little bit like this, and let's put these 2 inside an if, inside this if. So this part will be executed only if the both hits get the valid hits, like this. So still I don't think there will be any difference, but let's just check. Okay, right, now we know the 2 points. Now we need a way to find the angle between 2 points, because here, if the character is walking in a surface like this, we can see using these 2 hit points we should be able to calculate the angle we need to rotate the root bone. So if 2 hit points are like this, then by taking the difference of the y coordinate of these 2 points, we can get this height, and we can get this distance by calculating the length between those 2 points. So if this angle is alpha, then sine alpha equals h divided by this length. That means alpha equals sine inverse h divided by L. So let's see if we can implement that logic there. Float L equals vector 3 distance thigh hit dot point clavicle hit dot point, and h is equals not thigh, clavicle hit dot point dot y minus thigh hit dot point dot y. Now the angle equals math dot a sine do we need to use radians? It's okay. Let's get a sine h divided by L. Now let's print what's the value we get here. We don't need any of these now. We only keep this debug out. Okay, it's 0. Let's see if we get a difference result. Right, we get a difference result when I go there, and if I change, it should be minus. Exactly. Okay, now how do we convert radians to radians to angles? That should be simple. I just did a quick Google search. So actually radian phi means 180 degrees. Yeah, basic mathematics. So this is in radians, and if we multiply this by math dot phi and divide by 180, we should get the angle, right? Let's see. Oh no, no, what did I do wrong? Sorry, it should be other way around. Multiply this by 180 and divide by math dot pi. Alright, so here you can see we have 14 as the angle, and if I select this you can see 14 and it's minus. So yeah, I think that's because of the direction we are looking at. Okay, so now let's apply that angle to the root. And let's see what happens. Alright, we have to revert it. So how do we revert it? We have to, we can simply interchange this. Oh, actually we could multiply it by -1 also, but let's see. Okay, now you can see the character is rotated to that angle. Alright, so but this is not the final version, because in the next episode I want to find a way to align the legs to keep the legs vertical, because it doesn't look good like this, right? And also we need to smooth out these transitions as well, but let's look into that in another episode. Right, and if you would like to support my work, you can get the membership of the Patreon club. Link would be in the description below. And thanks for watching. See you in another episode. Goodbye.